Hello, my esteemed viewers. This is Medical Science Lecture Room. I'm delighted to have you back. In this channel, we run physics, chemistry, and mathematics lectures. We also educate our viewers at the comfort of their living room on medical conditions. In other words, we give medical tips or medical education to our viewers. This is to enable them stay healthy. But for today, our discussion is on physics, and the topic is vectors. Once again, my name is Dr. Godwin Obono. In case you're new to this channel, please don't fail to hit the subscription button. Do not also fail to turn on your notification bell so that once we make new video, you'll be forced to be notified. Again, share and like the video. Let's begin. Welcome back. Today's discussion is on vectors. You need to understand that in physics there is what we call physical quantities. In fact, the entire physics course is anchored on what? Physical quantities. Now, physical quantities can either be fundamental or derived. I have done a video on physical quantities, dimension analysis, and also how to derive the unit of physical quantities. So please, there will be a link for you to access those videos. Please, it's important. If you must have understanding of your physics. You need to have absolute understanding of what physical quantities are. Now, today we are taking what? Vectors. I need you to understand that physical quantities can be divided into what? Scalars. We have scalars and vectors. You can have some physical quantities are scalars, some are what? Vectors, some physical quantities are derived, some are what? Fundamental. But for today, we are looking at what? Vectors. Now, but before I discuss vectors, I would like to remind us of what scalar is, because now for you to have on the to appreciate vector the discussion, the topic vectors, there is need for you to equally understand what a scalar quantity is. And I'll quickly define what a scalar quantity is. A scalar quantity is a physical quantity that is specified by magnitude only. What that means is that a scalar quantity has a numerical value but doesn't have what? Direction. So that's why you see when we say mass is 50 grams, we can't say 50 grams we give you direction. No, because mass is a scalar quantity. So let's quickly take examples of quantities that are what? Scalar. Mass, I need you to write them down, because most or some exam objective you may find that we have mass, time, distance or length, temperature, speed, density, volume, energy. These are few examples of what? These are examples of scalar quantities. You need to know examples of scalar quantities. Now, sometimes they may give you, if you have scalar quantity more than one scalar quantity, they may ask you to find a resultant, what they call resultant, the resultant scalar. For example, if we say, remember we said an example of a scalar quantity is distance. Supposing we have this line and you use your meter rule to measure this line. Because there is no direction, you may decide, there is no specific direction, you may decide to measure either from here to here or from here to here. Now there's no specific direction. Remember that if there is specific direction, supposing they specify. In this case, if I indicate this, I have specified the direction. What this means is that I must start to measure from here this way. That means I have specified the direction. Whatever I measure is no more distance. It will be what? Displacement, and that is a vector. But because we are looking at what? Scalar, I will not indicate what? That arrow there. I need you to understand that you can take either measure from here, put your zero mark of your meter rule at this point, or you put it at this point. But if supposing you have measured and you have here 5 centimeters, and there is another line and there is another line, and you equally measure this, and you have this to be 10 centimeter, and somebody says, what is the resultant of this? Now, somebody probably gave you this and asked you, what is the resultant of this? What is the effective of this? Now, you need to understand, when you look at this, you discover that there is no direction. Because there is no direction, it simply tells you that this is what? A scalar quantity. And if it's a scalar quantity, please, what you need to do is simply to add the magnitude together. So if I call this one to be what? Scalar, the scalar A, and I call this one scalar B, it means that the resultant will simply to add the magnitude of A plus the magnitude of B. And that will be what? 5 centimeter plus 10 centimeter. And of course, that will be 15 centimeter. You see, the addition of two or more scalar is simply what? Algebraic, meaning that it's simple addition. It's simple. It is not as simple like that as that when you're dealing with what? Vectors. Now, so I will not want to dwell so much on scalar because this may not form most of your examination equations. So what you see in most of your exam is what? Vector quantities. So let's quickly look at vector. A vector quantity by definition is a physical quantity that can be specified by magnitude and direction. What that means is that a vector quantity has a numerical value and also has what? A direction. You see the difference between scalar and vector. Sometimes they can tell you what are the different, give two difference between scalar and vectors. Now, number one, you've seen scalars do not have what? Direction, while vectors have direction. You can also give examples of scalar and you give examples of what? Of vectors. Now let's take examples of vectors quickly. Examples of vectors. Now for vector quantity, let's take velocity is an example of a vector. Velocity displacement. Displacement is an example. Now force, weight, acceleration, momentum, electric field. These are few examples of what? Vectors. You need to know these examples. So these are examples of vectors. So now vectors have magnitude, vectors have what? Direction. So let's quickly look at what the resultant of what? Resultant of vectors. Resultant of vectors. Resultant vector is what we call vector addition. Vector addition. If you don't call it resultant, we also say vector addition. Sometimes they will tell you, if they don't use the word resultant vector, they may use the word effective vector or common vector or single vector. Different. So but the common word used or term used is what? Resultant vector. How do you calculate the resultant vector? Now, how do you calculate the resultant vector? I've shown you how to calculate the resultant scalar. Now, how do you calculate the resultant scalar vector? Please, for you to calculate the resultant vector, you need to know, or you need to ask yourself, what type of vectors am I given? What system of vector am I dealing with? First, there has to be it can either be parallel vectors. That means in any exams, whatever that is given to you can fall on either of these. So you may either be given parallel vectors or what we call perpendicular vectors. We also have the one we call inclined vectors. There is also what we call resolution of vectors. Resolution of vectors. All these cannot be treated in this video. So this video, I will take only parallel vectors. I will now do, there is another video for perpendicular, another video for incline, and there is another for resolution of vectors. So that means for just this topic, you will expect what? 4 videos. So that's why you have to subscribe to this channel. You have to subscribe to this channel. Once the videos are released like this, you will you just get to know that these videos are out. So please don't fail to do so. Now, parallel vectors is what, because this topic, this is something that in your conventional classes, it can take you 3-4 hours. So I can't treat all just within in this video, because it will be very lengthy. So I have to cut it. So please, today I will only dwell on what parallel. So let's discuss parallel vectors. Vectors are said to be parallel if they travel such that no angle is formed between them. So two or more vectors are said to be parallel if no angle is formed between them. Now, when do we say an angle is formed? As a science student, you know when an angle is formed is when two lines meet. So there can only be angle formed when two lines meet. So now in this case, we are telling you that a vector is said to be parallel, or a system of vectors said to be parallel, if these vectors do not meet at any point. So if I have a vector, for instance, this is a vector that run this way, and let's say I call this vector A. Supposing that is vector A, and I have another vector, let's say this is another vector, this is vector B, and this is vector A. Now let's say the magnitude of vector A is VA, and the magnitude of vector B is VB. And you're asked to find the resultant vector, Please, I need you to know that the resultant is always equal to the sum of the magnitude of the vector A and that of what? The magnitude of vector B. So you need to know this. Now, generally, for parallel vectors, for you to get the resultant, you simply do what? Add the two magnitudes. After you have thought of that, the next thing you need to do is to ask yourself, what is the directions of these vectors? Now, please, at this point, you will say that you ask yourself, what's the direction of these two vectors? You see that the two of them are moving in the same direction. Because they are moving in the same direction, you will give them the same sign. So I will simply say the magnitude of vector A will be positive vector A, and the magnitude of what B will equally be plus VB. I will not give minus. I will not give plus and minus because they are not moving in different direction. I will give plus plus. I will not give minus minus. Minus minus, because if you give minus minus, you will not say, it means that you are telling us that the vector, the answer will turn to what? Negative. The answer shouldn't be negative. So please, whenever you have the vectors to be in the same direction, give a positive sign to each of the magnitude. And so when you substitute this in here, you will now see what you're going to have. Remember, again, this resultant must have its direction. This resultant is also a vector. And how do you get the direction? Please take note. The resultant direction will be the same as the direction of the vector with the highest magnitude. For instance, for these two, this is the one that is the longest. Because this is longest, the direction is this way. So you will therefore expect that the direction of the resultant will be the same as this. So what I do? I will write this, because that is its direction. This is the direction. Remember, if you had these two with this, you expect that this line should be longer than the both of them individually. So this can be longer, and then this is my resultant. You can see the resultant is also facing this way, just like the direction of what? The A. You may not appreciate it because this is also going that direction, but I am not placing emphasis on the B, because the B do not determine the direction of the resultant. The direction of the resultant must be the same as the direction of the vector with the highest magnitude. Now let's take another example. Supposing I have this, for instance, I have this, and this one is also, let's say this is B, and this one is this, and this is A. And now, of course, if this is B, the magnitude will be what? B. If this is A, the magnitude will be what? VA. And you're asked to find, I want to describe how to get the resultant here. Now, know that generally, for parallel vector, resultant is always VA plus VB, or VB plus VA. What that means is that it doesn't matter, you can begin with the A or you begin with the B. It doesn't really matter which one can come first. But always remember that the magnitude, remember that VA, VB represent magnitude, represent numerical value. And so just add the two numerical value. That will give you the resultant. But before you add them, you must consider their direction first. Now, if I'm to consider their direction, I will not say, what is the direction of A? What's the direction of B? In this case, you see that they don't have the same direction. This one is moving this way, while this is moving this way. And because they are not heading the same direction, therefore means that I will be giving them opposite sign. And now I want you to get it right. The one that is the longest, give it a positive sign. The one that is the smallest, give it the negative sign. What do you see? From here to here will be shorter than from here to here. Therefore, this is longer. And so I will say VB will be what? Positive VB, while VA will be what? Negative VA. In this case, you see that the sign given to them are positive and negative. Reason is that they are not moving in the same direction. Here, it was positive, because they are heading the same direction. Now, if I have done so, you can see if I substitute this into this formula, this is the fundamental formula. This is the fundamental formula. If I substitute this there, this resultant will now, that was already VA plus VB, it will now be equal to, our VA is minus VA now, plus the VB, which is positive, and then this will turn to what? VB minus VA. You can now see that the resultant turns to what? VB minus VA. Now, having done this, is what you will now ask yourself, what is the direction of the resultant? I told you earlier that the direction of the resultant must be the same as the direction of the vector with the highest magnitude. Go back to the diagram. If you go back to the diagram, what do you see? This vector is heading this way, while this one is going this way, and this one is longer. And because this is longer, it means that the resultant will also go this direction. So I will do this and say this is what? My resultant, which is what? VB minus VA. I have just used this to describe how to calculate the resultant. We can now take specific example so that this I have explained will be much clearer. We have these two questions. Let's see how we can answer them. Now look at the first question. The first question is that the vector A is 5 centimeter and is going this way. Vector B is 10 centimeter and is going this way. The question is calculate the resultant. Now we will say that the resultant is equal to, remember I said it's always VA plus VB. That is to say, just add the two magnitude of the two vectors. That's what this means. Now, having done so, I will now say what is VA. Now our VA, I will now ask myself, what are their directions? Both of them are heading the same direction. So I will give them positive, like I said earlier. So this will be plus 5 centimeter, while the VB will be what? Plus 10 centimeter. And so if I substitute this, the resultant therefore will be equal to VA plus VB. Remember, it is either VA plus VB or VB plus VA. And so if you substitute, this will give you 5 cm plus what? 10 cm. And the answer will be what? 15 cm. Now, remember that 15 cm represent the magnitude of the resultant, and you are supposed to indicate the direction, because what they gave us here, it has a direction. This is the direction. Please, at this point, I want to remind you, I want to tell you that the direction is always indicated. Direction at any point in time, you can either use the arrowhead to indicate direction, or you can use angles to indicate direction, or the Cartesian system. You can use either of that to locate what? The angles. Now, to locate direction. Now, if we want to, that's why here, it is the arrowhead they use to indicate direction. So, if we want to indicate the direction of resultant here, we must use the arrowhead as well. And so, that direction will be the same as the direction of the vector with the highest magnitude. Which one has the highest magnitude here? It is vector B. Therefore, vector B runs this way. That's why we will also draw that of the resultant here, and we write here 15 centimeter. And that becomes the answer for this one. Now let's look at this other one. Now here we have a vector A going down, while this one is going up. Again, remember the resultant is always what? VA plus VB. Now at this point, we ask ourselves, which one is are they moving in the same direction? They are not. This one is going down, this is going up. they are not moving towards the same direction. And so one must be positive, one must be negative. I told you, always give a positive sign to what? The one that has the highest magnitude. And so when you do that, it means that our VA will have what? A positive 20, will be positive plus 20 centimeter, while VB will be what? Minus 10 centimeter. If you substitute this into that, of course, we had VA plus VB. If you substitute, you will now have what? 20 centimeter plus minus 10 centimeter. And that, of course, will be 20 centimeter minus 10 centimeter. Where plus times this will be minus, and the answer will be what? 10 centimeter. But you will not leave it just as 10 centimeter. You must indicate the direction. Remember that this one is longer than this one, so the resultant direction will be the same as this vector A. And so you draw it this way, and then this will be what? 10 centimeter. Or if it is an exam where they may write the direction in words, you may say that the resultant is 10 centimeter in the direction of vector A, because vector A direction is here. Everybody who listen to that will understand. So at this point, I want to believe that you have understanding of what parallel vector is. And please, like I said earlier, go for other videos so that you have a better understanding of all of these concepts. If you have any problem, go to the comment section, drop your comment there, I will respond. Again, hit the subscription button. Also, turn on your notification bell so that once new videos are released, you will be forced to be notified. Also, share and like this video. Thank you.